Testing a pressure relief valve. This is what I read in a lot of troubleshooting books. If you can set a pressure relief valve at its predetermined pressure, it's in good working condition. All right? Let me show you why that's a myth. I'm going to take the lock off this machine and I'm going to start it up. I have a pressure gauge here and I've set that valve at 1000 psi. That was a requirement, 1000 psi. Let me see if that's the pressure that I have when I deadhead the cylinder. I have 1000 psi. That's the required setting. I'm going to go to the screen. And I'm going to go into the instructor login. And I'm going to select the manual. So what this has is if you want to create your own problems with any valves or build your own circuits, then you can go into this screen here, which faults any component on the simulator. So now what I'm going to do right now is I'm going to fault the direct operated relief valve, which is this valve right here that I just verified was set at 1000 psi. Now I'm going to go and see what the setting is again. 1000 psi. So according to the industry's recommendation, for the most part, I can't speak for everybody, this valve is in perfect working condition. All right. Here's what I'm going to do. I'm going to lock the machine out, because when you're doing MicroLeak testing, you're locked out. And I'm going to MicroLeak test the valve, which is the only way to test this valve. There is no other way for a definitive outcome. So here's what I'm going to do. All I'm going to do is connect one port. Now, obviously, there are special adapters. The MicroLeak test is a kit. So I've got a wide variety of adapters. But I'm not here to sell the kit right now. I'm here to show you how this works. So I'm going to pull off only one line, port 1. I'm going to connect a T. And the first thing I want to do when you use a MicroLeak test pump is to make sure, every time you use it, that it, in and of itself, is not leaking. So let's do a MicroLeak test on the MicroLeak test pump. So here we go. I pressure up, and I hold, which means this is in really good condition. All right, so I've done that. Now I'm going to go and connect a line from my MicroLeak test pump to the inlet port of my relief valve. And remember, you always test going with the flow. And I'm going to MicroLeak test this valve. See, it failed the test. Yet, it was set at the recommended pressure. So that whole theory that if you can set a pressure relief valve at its predetermined pressure, it's fine, is out the window. That's never been. In fact, when I question that, just because I understand basic hydraulics, think about that. When you set a pressure relief valve, right? If 3 to 5% of the oil is leaking across a relief valve when it's worn out, and 3 to 5% of the oil is leaking across a relief valve, which is an unacceptable amount of leakage, right? If I deadhead and I send, let's say, 40 or 50 GPM through the valve, if only 5% of that oil can leak, what does the other 95% have to do? It has to open the valve to get through. Well, if you can open the valve, you can set it. That's how it works. So, what I've seen here definitively, this valve is no good. And there's no coming back. There's no fix for it. I'm not ever going to tell anybody to go in the field and start taking this thing apart, because I respect the fact that they might not be competent to do that. So your job right now is to help the production people out. Get another valve, get it on the machine, set it, get it going. Now let me show you let me take the fault out. Here, I'm going to disconnect the fault. Now look what happens on a pressure leak test. Here we go. As soon as I get resistance, I've got a good valve. So I'm going to go up to cracking pressure, because it won't rise beyond cracking pressure. Go up to cracking, hold. Now, the manufacturer does give leakage rates on these valves, about 6 drops per minute. Through my research years and years ago, I found that if I drop 100 psi, when I was actually at that time measuring the leakage into a test tube, that 100 psi equated to 2 drops of oil. So, for those folks who wanted to know about MicroLeak testing and what MicroLeak testing is, you've just seen it. And it works on all the valves that you're going to have. Well, let's just cut to the chase. The only components we can test with flow meters, or should, are hydraulic pumps and hydraulic motors. The rest, the flow meter is not going to work. First of all, the scale isn't going to work. In other words, if you've got for argument's sake, these are 2-gallon a minute flow meters, then they only start reading at 2/10. So if you've got a 30 GPM, because you've got a 1-inch line on your leaf valve or a 3/4-inch line, you might have a 30 GPM or 50 GPM flow meter. They only start reading at 5 GPM if it's a 50. My problem is below that, I can't see it. It's off the radar screen. So when you think about it, there is really no other way. So in the next couple of months, we're going to, obviously on the Fluid Power Academy, we're going to be posting a lot of troubleshooting training videos, specifically to these valves that we have difficulty with. So visit our www.fluidpoweracademy.com. I want to thank you for your time, and I encourage instructors to start teaching this technology. And by the way, remember, taxpayer-funded schools, my training is complimentary for taxpayer-funded schools. You don't have to buy my trainers in order for me to help you understand how to do MicroLeak testing by any means. I'll help no matter what. So let us know what we can do to help you. In the meantime, stay out of COVID's way and be safe. Make sure that machine is locked out and never test to the atmosphere. Thank you.